Ever wanted to create images that stay perfectly consistent in style? Or turn your old photos into bold, artistic transformations? You don't need complex tools because the most powerful style transfer solution is here, the USO method. Hello everyone, I'm Sotai. In my previous video, I introduced UNO, a method that helps you keep any character consistent, even non-human ones. And just recently, ByteDance released a new method called USO, designed to ensure style consistency across images generated from a reference photo. As you can see in this demo, USO can transform styles from a reference image with remarkable accuracy. The results are not only impressive but also highly aesthetic. Even more creatively, USO allows you to combine two different styles from reference images to create something entirely new and unique. The best part is that you can also apply new styles to your existing photos, while still preserving the original subject's core features. Sounds amazing, right? So in today's video, I'll walk you through how to build a USO workflow in ComfyUI, optimized to run on just 8 GB of VRAM, so you can create stunning style-transferred images right on your own PC. Alright, let's dive in. First, let me show you how to build a basic workflow. In our first example, we're going to generate a brand new image while keeping the style from your reference image. And of course, the very first step is to load the required models. The USO model is basically a LoRa fine-tuned on Flux 1Dev, so we'll need to load the main Flux 1Dev modules. Flux 1Dev UNet, Dual Clip, and VAE. Since the VAE is only used later in the decoding step, I'll load it afterward. And after loading the Flux UNet, we load the USO LoRa into the UNet model. I've already covered these nodes in detail in my previous video on Flux 1Dev, so feel free to check that out if you missed it. In addition to the Flux models, we also need a module to extract style information from the input image. For this, we'll use a vision encoder, and specifically, the method's authors chose SIGLIP as described in their paper. And of course, we'll also need a projector to map the extracted style information into the latent space of Flux 1. I'll leave the download links for these models in the corresponding Patreon post, so you can easily access them. And next, it's time for the inputs you'll be working with. Of course, we'll need a reference style image and a prompt to generate the content you want. So here, we'll use the load image node and the prompt clip node. We also need to initialize a latent image for Flux to perform the denoising process. In this example, I'll set the shape to 1024 by 1024, which is the default standard for Flux. Of course, you can adjust the width and height to your preferred size. Just keep in mind one important rule. Both values must be divisible by 16. Next, we'll encode the inputs one by one to feed information into the denoising process. The prompts will be encoded using the dual text encoder, and all we need to do is connect the nodes together. As I mentioned in the introduction video about Flux, Flux doesn't use negative conditions, so here we'll set up a zero-out condition for the negative side. The reference image will be encoded by SIGLIP, so that's why we have the clip vision encode node here. And then its information will be projected into the latent Flux through a newly integrated node in ComfyUI core called USO Style Reference. The outputs from both encoding processes will then be sent into the K-sampler node, which handles the denoising step. At this stage, we'll connect the inputs model, positive condition, negative condition, and latent image to the corresponding outputs from the encoding nodes. I'll set the CFG scale to 1, which balances the prompt with the style information from the reference image. Finally, the denoised result just needs to be decoded using Flux's VAE, and we'll have our final image. To make it easier to see, I'll also add a preview image node so we can check the output right away. And that's it. We've just finished building a workflow that generates images in the style of your reference image. Pretty simple, right? Now, let's take a look at the results and see if our workflow works as expected. Here, I'll use a reference image of an object made out of yarn, giving it a soft, fuzzy, and cozy texture. The prompt is kept very simple, Mickey Mouse. What I expect is that the workflow will generate an image of Mickey Mouse crafted from soft yarn. Let's take a look at the results together. Pretty cool, right? With just a simple prompt, I was able to create an authentic wool version of Mickey Mouse. The style in the image stays almost identical to the referenced soft, fluffy yarn for the character, a simple light blue background, and an overall cozy, warm vibe. What's even more impressive is how naturally the subject and style blend together, just like an original photo. No glitches, no artifacts at all. So our workflow is running smoothly. Now, let's take a look at a few more examples to get a better sense of what this solution can really do for this task. Now I'm going to try a different reference image, Leonid Afremov's Misty Mood Night, which is done in an oil painting style. Let's see how Mickey Mouse looks when reimagined in this oil painting vibe. And the result is just as expected. Mickey Mouse keeps his familiar shape, but the whole image now carries those bold brushstrokes, rich colors, and the depth unique to oil painting. Looking at it, you get the sense that this isn't just a cartoon character anymore. It truly feels like a piece of art you'd see hanging in a gallery. That's the magic of USO. It not only preserves the character, but also fully captures the spirit of the chosen style. Let me try turning Spider-Man into an oil painting, since I'm a big fan of him too. Pretty awesome, right? I'm seriously thinking about hanging this one in my bedroom. Everything looks so good so far, so let me crank up the challenge with a style that's even hard for me to imagine. Spider-Man in traditional Chinese calligraphy style, just like you see here. Let's find out what kind of result the workflow can give us. Oh, that's amazing! The workflow is still working beautifully. As you can see here, the legs were generated with those signature ink strokes that really capture the essence of calligraphy. Super creative, right? You can experiment with all kinds of different styles, and I'm pretty sure the results will surprise you every time. Alright, so that was our test with a single reference style image. But what if I want to reference more than one style image, like the demo on USO's homepage? For example, I'd like the generated picture to blend both the oil painting style and the Chinese calligraphy style. The answer is super simple. After feeding the model with the first style reference, you just pass it through the USO reference style node again with the second image, exactly like I'm doing here. Easy, right? Now let's check out the result we get when we mix these two styles together. The result is truly impressive. You can see how the colors blend together so smoothly. The oil painting style keeps its vibrant tones and thick textures, while the calligraphy strokes weave in beautifully, adding bold, expressive highlights. The whole image feels like Spider-Man has just stepped out of a masterpiece that fuses East and West, tradition and modernity. What's most important is that even with two seemingly opposite styles, USO still preserves the character's identity. Spider-Man looks perfectly intact, without any distortion or loss of essence. This really shows off USO's creative power, the ability to harmonize multiple styles in a single image, turning them into a unique, artistic, and consistent work of art. So, I've just walked you through how to build a workflow that can generate images in any style you want. But up until now, the subjects have been generated randomly. if you'd like more control over the subject, or in other words, if you want to transform an existing image into a brand new style, USO has you covered for that too. For example, let's say I already have a character image. I'll tweak the workflow so that this character can be regenerated in the style I want. To make sure the subject is preserved, all you need to do is use the reference latent node together with USO's reference method. Specifically, I'll use the VAE to encode the character image, then feed it into the reference latent node, and connect that to the flux context multi-reference latent method node. In the method section, just select USO. We'll also need to add a guidance scale node and set its value between 2 and 3.5, so flux follows the new condition properly. And that's it. Your workflow is now upgraded with the ability to control any character you want. Okay, let's check out the results after those adjustments. Naturally, we'll tweak the prompt to fit the character we provided. The prompt is, a woman is standing on a street at night. Alright, let's see how it turns out. Pretty amazing, right? My character has been redrawn in an oil painting style, blended with a touch of Chinese calligraphy. At the same time, USO perfectly preserves the character's key traits, like the long white hair here, or the pointed ears there. And the style stays completely consistent with the two reference images I provided earlier. So with just a small adjustment to the positive condition, you can fully control the output for any character you want. The workflow now gives you the freedom to create any style you like, with any character you choose. And finally, let me show you how to optimize VRAM usage for this workflow. Right now, running it requires around 21 GB of VRAM, which is pretty challenging for most users with limited GPU resources. So, let's optimize it so you can run the whole workflow with just 8 GB of VRAM, yes, only 8 GB. The optimization method is similar to what I explained in previous videos. You'll need to use a quantized model. This reduces computation and memory load, while only sacrificing a small amount of quality. For this demo, I'm using Flux Dev version Q3KS. If your GPU has even less than 8 GB VRAM, you can experiment with Q2. I'm also using the GGUF version of the T5XXL model, again in Q3KS format, to keep VRAM usage low. And one last but very important step. Use the Purge VRAM node to clear out unnecessary variables from the GPU. Place this node right after Clip Vision Encode, VAE Encode, and after the K-sampler. With all of that set up, everything is ready, so let's check out the results of this optimized version and see exactly how much VRAM it uses now. Oh, my character is still fully preserved, and the style in the image turned out just the way I expected. And here's the optimized VRAM usage, see that? It's down to only about 8 GB at maximum. Pretty amazing, right? With just a few simple tweaks, you can now run this workflow on your own personal computer and start creating images in styles you've never seen before. So that's my complete walkthrough on how to build a USO workflow in ComfyUI. Whether it's for generating consistent styles, transforming a character into a new style, or running the workflow smoothly on a low VRAM computer. I really hope you watched the whole video to catch all the little tricks I shared along the way. If you found this video helpful, don't forget to hit like and share so more people can discover my channel. Thanks so much for watching. See you next time.